So the next thing that we're going to do with quadratic functions is completing the square. So completing the square. The goal of completing the square is we're trying to rewrite a quadratic function in a different form. So we have a quadratic function that was ax squared plus bx plus c. What we're trying to do is rewrite this. We want to rewrite this as a times x minus h squared plus k. Now you might be wondering why in the world would we want to do this. It's helpful for a couple reasons. You can solve quadratics using this. Also, it's easier to graph. It's easier to graph if you have it of this what's called the vertex form than it is of the standard form. So standard form is first one, vertex form is the second one. So we're just going to do an example, and then I'll write out the steps as we're going. So we're going to complete the square. On f of x, which is 2x squared plus 8x minus 8. So I have f of x is 2x squared plus 8x minus 8. First thing I'm going to do is group my x terms. In my problem I have two terms that have x's in them, so I'm going to group those together. So all I did was put parentheses around my x terms. Secondly, factor out a. So a was 2, so I'm going to factor that out of everything in parentheses. So I'll get x squared plus 4x minus 8. I didn't factor out the 2 from the minus 8, I only factored out from the x terms. 3, take the new b term and divide by 2. So I'm going to put a little bit of room in here. So my new b term is my new linear term, which is a 4. That's my new coefficient. So 4 divided by 2 is 2. So I'm going to write that right here. What I do with that is take this, square it, and add inside the parentheses. So this is the hardest step. I took my 4 divided by 2 and I got 2. 2 squared is 4, so I add a 4 right there. Step 5, fix what we just did. So when I say fix it, this is what I mean. Going from this third line to the fourth line, I added a 4 on the inside, which means these two are no longer equal. So I need to fix that. So when I put a 4 right here, really because of the 2 on the outside, I added an 8. So in order to counteract that, I need to subtract another 8. And then the last step is to rewrite. So the nice part, and this is why I wrote this below, is because this middle part is always going to change into x plus whatever this is. So these two numbers will always be the same. And then on the outside, I have my minus 16. So let's go through this one more time. To complete the square, first thing group my x factors. Then I factored out my a, so I factored out a 2. Next I took this new b term, divided it by 2. Squared it, put it here. Then I got rid of what I just did. So I added an 8 by putting a 4 there, means I need to subtract an 8 on the outside. Next, factored it, sorry about the squared term there. This term, whatever I did when I divided by 2, will always go here. So now I've rewritten this as 2 times x plus 2 squared minus 16. Now again, why are we doing that? Because now it's easy to find the roots. So let's say I want to find the roots of our f of x. Well, our f of x was 2x squared plus 8x minus 8. Now you could have used the quadratic formula and that's completely fine, but also this is 2 times x plus 2 squared minus 16. Let's set that equal to 0. First thing, move the 16 over. Now I can divide by 2. Now I can take the square root. Keep in mind when you take the square root, there's a plus and a minus. So I could do the negative square root of 8 or the positive square root of 8. Then solve for x. So x is negative 2 plus or minus the square root of 8. So if you have factored this, if you've completed the square, then you can solve for x a lot easier than the quadratic formula. But really it's up to you. So that's how you complete the square. Also, once you have it in this vertex form, it's easier to graph. So the vertex is always going to be hk. So in our example, our h here was -2. So if you go back, remember that it's always of the form ax minus h squared plus k. So this is kind of what you want to be thinking. Our problem was x plus 2, which means my h is -2. So our h is -2. Our k was -16. So that means our vertex is at -2, -16. Then, is my parabola opening up or down? Well, my a term is positive, so it's going to open up. So, I could sketch the graph like that by plotting the vertex and then saying that it is a parabola pointing upwards. So that's how you could use this new vertex form. Let's do one more example on completing the square. Let's complete the square. On f of x is 3x squared plus 9x plus 1. So let's start by writing our function. So 3x squared plus 9x plus 1. The first step in completing the square was to put together all my x terms. So 3x squared plus 9x. Next, factor out my a. My a was 3. So I'll get 3x squared plus 3x. Leave a little bit of room. Next, divide by 2. Three divided by 2 is 1.5, or I could just leave it as 3/2, that's fine. Next, square this term, so I get a 9/4 there. Now fix it. The problem is that when I put this term there, I added in a 27/4. How do I know I added in a 27/4? Because the 3 distributes. So I need to subtract. Now rewrite it. So this will be x plus whatever term is here, so 3/2 squared. 1 is the same as 4/4, so this will be minus 23/4. So the hardest step is going to be dividing this b term by 2 and then squaring it. So I divided by 2 and got 3/2, square it to get 9/4. Now it's absolutely fine to leave it as a decimal. That's fine with me. Just remember, whenever you fix it, you're not just subtracting a 9/4, you got to subtract the 3 times 9/4 because this 3 will distribute. So, if I was going to graph this, or sketch the graph of it, what's my vertex? My vertex is going to be -3/2 because it's x minus h, -23/4. So that's -3/2, -23/4. Is my parabola opening up or down? Opening up because 3 is positive. So that's how I could sketch my graph. I also could set this equal to 0, move the 23/4 to the other side, and then divide by 3, etc. But that's how you're going to complete the square. So just go through those steps and you'll see how to complete the square.